Welcome to the C2 Pipeline Anatomy of Ammunition Ballistics Lab. During this lab, you will learn about centerfire ammunition, its different parts. You will learn about spent slugs. You will learn about how firearm barrels are manufactured. You'll compare bullets to decide the direction of the twist. You'll measure class characteristics, and you'll look at lands and grooves. You will use this information to determine whether any of your practice bullets match the bullet from the crime scene. Let's get started. A centerfire cartridge is made with four main components. When it's all together, it looks like the figure that is circled. A bullet can also be called a projectile. Bullets are typically made of lead and can be jacketed or covered with copper. The bullet in this picture has the brown arrow. Gunpowder can also be called propellant. When gunpowder burns, it produces large amounts of gas. The expansion of this gas pushes the bullet through the barrel. The cartridge shown here with the green arrow is typically made of brass. Cartridge cases hold all the parts of the cartridge together. The primer can be seen with the red circle. It contains a shock-sensitive explosive which produces sparks when hit by a firing pin. These sparks, in turn, ignite the gunpowder, causing it to burn. Cartridges are a combination of a projectile, the bullet, a propellant, gunpowder for example, and a primer, the explosive cap, all contained in one metal package. Caliber is a general term that refers to the approximate diameter of the bullet. A .38 caliber bullet has the same diameter as a .357 Magnum bullet, so caliber is a general term. As shown in this picture, bullets come in different shapes, sizes, and profiles. When bullets break apart from contact, such as hitting cement, the pieces are called fragments. Even tiny fragments have forensic value. At this time, you will get your supplies so that we can examine a spent slug and some casings together. We'll pause the movie so that you can gather your supplies. In your Ziploc bag, you have an example of a casing and some spent slugs. At this time, please take the casing out of your bag. It looks similar to the ones in this picture. And also take out just one spent slug. Then if you would, please zip the bag closed again. We'll pause for a moment so that you can get a casing and a spent slug out of your bag. Forensic examinations in firearms typically identify and address two main questions. The first question: were the question casings, usually crime scene evidence, fired from the same gun as the test casings? The second question: were the question bullets, spent slugs, usually from the crime scene, were they fired from the same gun as the test bullets? The bullets that you have in your bag are the test bullets. We will be examining the spent slugs today. The casings are there just so that you can get a look at what a casing actually is. So how are firearm barrels manufactured or made? Firearm barrels have grooves cut or pressed in the bore, which produce rifling. These grooves are cut in a spiral pattern, as you can see in this picture. Between the grooves are raised areas. These are called lands. Some bullets may have the same caliber, number of lands and grooves, and direction of twist. In order for a bullet comparison to proceed, all class characteristics must agree. In the example shown in the picture, all of the class characteristics agree except the width of the lands and grooves. You can see this in the picture where it's split from two different bullets where there is a red marking and a blue marking. Obviously, these lands and grooves have different widths. Because of this difference, we know that these bullets have not come from the same firearm. Each firearm barrel has 4 class characteristics. The caliber, which is the bore diameter, sometimes referred to as .22, .45, .357. The number of lands and grooves, the direction of the twist, and the width of the lands and grooves. As you can see in this picture, the direction of the twist is to the right. These pie shapes go toward the right. There are 4 yellow areas which are the lands, 1, 2, 3, 4. And there are 4 grooves, the white areas, which also go to the right. This barrel is labeled 4R because there are 4 lands and 4 grooves and they are going to the right. As you can see in this picture, this barrel is labeled 6L as there are 6 red lands and 6 grooves. So it is labeled 6L. Some calibers' class characteristics overlap due to their relative size. For example, .380 and 9mm are .355 inches in diameter. A .38 Special and a .357 Magnum are actually .357 inches in diameter. Because only 0.02 of an inch separate all 4 calibers, they are considered the same class. The caliber is the barrel diameter. It can be measured in either metric or English units. Common calibers measured in metric units include 9mm. Common English calibers include .357 Magnum, .22, and .45. This refers to the width in inches. There are 2 types of rifling. They're classified as being either cut or polygonal. Polygonal rifling has a smooth transition between the lands and grooves. Cut rifling has defined shoulders. As seen here, polygonal rifling is very smooth between the lands and grooves, whereas the cut rifling has a very distinct cut between lands and grooves. All class characteristics are measurable. The caliber, which is the diameter at the base of the bullet, is measurable. The number of lands and grooves, as shown here, counted with the numbers. The widths of the lands and grooves, as shown with the red and green arrow, and the direction of the twist, shown with the purple arrow. In this case, the direction of the twist goes to the left. The twist is determined by sitting the bullet on a flat surface and observing the direction of the rifling. As shown here, this bullet has a left rifling. And this bullet, the direction of the twist is to the right. gun barrels have the same twist as the slug that comes out of them. All of the measurements that we will be doing, we will use calipers. At this time, we will pause to do a short exercise to learn how to use calipers. We will now examine and record the class characteristics for the slug that you took out of your bag earlier. Remember, rifling is classified as being either cut or polygonal. Look at the bullet that you took out of your bag to decide whether it has polygonal rifling or cut rifling. Polygonal rifling has smooth transition between the lands and grooves, and cut rifling has defined shoulders. We will pause at this time to determine the rifling and record it on the data analysis sheet. Our next step will be to count the lands and grooves. We'll count the grooves of the bullet. You can place a small mark with a felt tip pen or your pencil to mark where you're beginning to count so that you don't keep counting, as we will be going in a circular pattern. We'll pause at this time to count the lands and grooves and record it on the data analysis sheet. Now we will look at the direction of the twist. It's determined by sitting the bullet on a flat surface, and you'll observe the direction of the rifling. Does the rifling go to the left or to the right? Once you've determined this, record it on your data analysis sheet. We will pause at this time to determine the direction of the twist. You will use your calipers to measure the width of the lands and grooves. Don't forget to zero out your calipers before measuring with them. As shown in this picture, you put the very nose of the calipers at a land or groove and measure the width. You only need to do this for one land or groove, as they are spaced evenly apart in the barrel. We will pause at this time to measure a land or groove. We also need to record the mass of the spent slug. At this time, you will go and weigh your spent slug and record it on the data analysis sheet. We'll pause at this time so that you can mass your spent slug. One of your materials is a bullet reference chart. If you notice on the reference chart, the diameter of a 9mm slug and the diameter of a .38 special slug are very, very close. The 9mm is 0.355 and the diameter of the .38 special is 0.357. Using the different weights, they are shown in grains, that will help you to determine whether the bullet is a 9mm or a .38 special. We'll pause at this time so that you can determine the type of bullet you have measured the class characteristics for. Now that you have practiced with one of the spent slugs, you'll go on your own to determine the type of bullet for the other slugs in your bag. But first, let's listen to the scenario so we know what we're looking for. Once you're done with your practice slugs, you're going to compare them to a slug from the crime scene to see if it matches. So here's the case synopsis. police responded to a shootout involving many shots fired. When the police arrived, all of the suspects had left the scene. 10 fired slugs were found in cars and trees in the area of the shootout. The police asked several people in the area of the shootout what they had witnessed. A few of them said that they had seen Jimmy Chu running from the scene. The police obtained a search warrant for Mr. Chu's home and went there to look for any evidence. When they got there, they found Mr. Chu in his garage sawing a firearm into pieces. They took all of the pieces of the gun with them, including the gun barrel. Mr. Chu was taken to the cop shop to be questioned. When Mr. Chu was asked about the shootout, he reported that he was nowhere near the area at the time of the shooting and that his gun could not have possibly been used because it was at his home. The crime lab is requesting the following. After relaying Mr. Chu's account to the crime lab, the police want to know if his gun was used at the shootout. It is your job to determine if the evidence matches any of the practice slugs that were fired from Mr. Chu's gun. When you have finished with all of your practice slugs, you'll be given the evidence slug for comparison. Let's begin our investigation.